Hi everyone, somebody requested for me to answer question 8 from the second tutorial sheet, and what I'm going to do is I'm going to answer the first part and I will leave the second part because the first part is a little bit complicated compared to the second part, but B is straightforward. Once you know how to answer the first part there, but B will be very simple for you. So the first thing that you have to see or that you have to look at in this question are the trig ratios that has been given. When you look at the question, we're being told to find tan alpha minus beta and tan alpha plus beta, but in the question itself we've been given sign, meaning there is something that we need to do in order for us to get tan. Because our aim, looking at these questions are compound angles. Yeah, these questions are compound angles. So when you look at this format, it's in this. This is tan, meaning you have to use. There's an identity for tan that you're supposed to be using in order to find the solutions for such questions. So the identity is this one. So the identity says tan A plus B is equivalent to tan A plus tan B over 1 minus tan A tan B, and tan A minus tan B is equivalent to tan A minus tan B over 1 plus tan A tan B. Yeah, so this is what we're going to use in order to answer these questions. This is what we're going to use. So first of all, we need to find means in which we're going to get tan from sine alpha. So when you look at our formulas here, you discover that there is nothing like sine theta in these formulas. Yeah, in these identities, there is nothing like tan theta. There is only tan throughout the identities, meaning there's a way that we can use, or there's something that we can do in order to change this sign into tan theta, tan alpha and tan beta. So let us begin. First I will start by bringing this here, but it's better for you to master these because they are not given in the exams. Sometimes they give if you are lucky, but in most cases they don't give, so you just have to know it by heart. Alright, so now we can start. Sine alpha is equal to this is 3 over 5, and again they are telling us to say this alpha is in the first quadrant. So what this means, when you have the quadrants like this, sorry for drawing in pen, yeah, they simply mean this sign is in this angle alpha is there, it's in the first quadrant. Yes, so when you look at this now, what we're going to do is we're going to draw a triangle. I'm going to draw a triangle which is in the first quadrant like that. Yes, so my alpha is there. So this is my alpha. So again, what you have to put in mind is that when writing such questions, you need to also know this SOHCAHTOA. You need to understand what this means. So SOHCAHTOA, when you look at SOHA, it's just sine x is equal to this O opposite over hypotenuse, then K means adjacent over hypotenuse, T opposite over adjacent. So this is the triangle, and then if this is our x, meaning our opposite to the x, the opposite part to x is this one. That's why it's even called opposite. And then this one is the adjacent, and then the hypotenuse is always the longest side. So we go back to our question. So sine theta is we know that sine theta is opposite, according to SOHCAHTOA, is opposite over hypotenuse. This is our sine theta. So meaning this 3 is opposite. I'm going to put 3 this side, and then this 5 is my hypotenuse. And then when you use what we call Pythagoras theorem, you discover that 5 squared minus 3 squared, you get 16, and the square root of 16 will be 4. So having gotten this, we can now find what our tan alpha is from this triangle. We know that tan alpha is nothing but opposite over adjacent. This is according to SOHCAHTOA. We said tan theta, which is tan x in this case, is equal to opposite over adjacent. So we go back. So tan theta is nothing but what? What is our opposite in this case? Our opposite to this is 3 over, and then what is my adjacent? My adjacent is 4. So in short, I've gotten my tan alpha. So now all this now even becomes useless, because what I wanted is just tan alpha. I just wanted tan alpha. So tan alpha is there. We also now get tan beta. Sorry. Yeah, we also get tan beta. Alright. According to the question, we know to say, we've been given to say sine beta is equal to 15 over 17. So sine So 15 over 17, and they are telling us to say this angle is in the second quadrant. What do they mean? We go back to the same triangle. So a triangle which is in the second quadrant looks like this. And then if this is my beta, if this is my beta, then my opposite, according to sine, we know that sine is equal to opposite over hypotenuse. So my opposite will be this now. This is 15. And then my hypotenuse will be 17. And then when you calculate properly, you discover that using Pythagoras, we discover that the adjacent will be 8. So now we can even get our tan from there. Tan beta is equal to, so we know that tan theta is always opposite over adjacent. So which one is our opposite in this case? Our opposite is 15. So our opposite is 15 over, our adjacent is what? Is 8. Yes. But remember, the question is saying beta is in the second quadrant. And we know to say tan is negative in the second quadrant according to this. We know that in the first quadrant all the trig ratios are positive. Then in the second quadrant only sign is positive, and then in the third quadrant only tan is positive, and then in the fourth quadrant only cos is positive. So having seen this, having known this, we know to say tan is negative in the second quadrant. Hence we're going to indicate a negative here, since the question is saying beta is in the second quadrant, and we know to say tan is negative, so we're going to indicate a negative there. So from there now we can start solving the question. So this is all I needed, so I'm going to erase the rest. I'm going to erase this. Yes. So this is my tan beta, and I also have tan alpha there. Tan beta and tan alpha we found. Now we can use one of these formulas to solve the above questions. Our first question was asking us to find tan alpha minus beta. So tan alpha minus beta, this one even becomes more simpler now, because we're just going to be putting our values that we've already found in this formula, this one here. So tan alpha minus beta is just the same as tan A minus B. So we're going to use this one. So where there is A, I'll be putting alpha. Where there is B, I'll be putting beta. Then where there is tan alpha, I'll put 3 over 4. Where there is tan beta, I'll put negative 15 over 5. So in short, what I'm trying to say is, the question is, what I'm trying to say is this: tan alpha minus beta, like this, is equal to, well, it's equivalent to, so we say tan A. What is our tan A? Which is tan alpha. Tan alpha is 3 over 4. So I'm going to put, or maybe let me rewrite this one in terms of tan alpha and tan beta. So this will be tan alpha, or let me not even do this, let me just go straight. Okay, so tan alpha in this case is just the same as tan A. Tan B is equal to tan beta. So while there is tan A, I'm going to, when there is tan A, I'm going to put 3 over 4. So tan A, there will be 3 over 4 there. Then minus, while there is tan B, I'll put negative what? 15. I'll put negative 15 over 8, like this, and then over everything over 1 plus, then while there is tan A, I'll put 3 over 4. Where there is tan B, I'll put negative 15 over 8. So when you solve this, you discover that your tan alpha minus beta will be nothing but equal to what? Negative 84 over 13. So this is the final solution. This is the final solution for the first part of question 8a. And then the second part of question 8b is just a matter of using this. Meaning where there is tan A, you put that, you put 3 over 4. Where there is tan B, you put negative 15 over 8. And then you solve the equation. You'll find the final answer there. Same applies to the second part of question 8. This one is actually even straightforward because there will be nothing like using triangles to find tan, but you just go straight. You take where there is tan alpha, you put that. Where there is tan alpha, you put negative 2 over 3. Where there is tan beta in these equations, you put 3 over 5. 3 over 5, yes. And then you find the final answers. This one is straightforward. This one is straightforward. Yeah, this one is straightforward. You don't even have to worry. You just go straight. You plug in all the numbers that you've been given, tan alpha and tan beta. You even find your final answer. So thank you for watching the video. Don't forget to subscribe to my channel.